All right, so we should be recording right now. So let me get rid of this and let me get rid of that. All right, so we're going to continue talking about arrays and pointers, and we're going to talk about functions today. So functions other than main. So main is a special function because it's the function that executes when we hit play, but we can create other functions just like we do in Python and other languages. So I'm going to quickly review what we did. So yesterday we said we can create an array of some data type. Say, for example, int, I can say my array, and I can do something that looks like this. And then I can say my array 0 equals to some value. My array 1 equals to, some other random value, and my array 2 equals to some value. And I did say that this kind of the line below will it'll allocate space. In this case, it'll be 12 bytes. And then it'll essentially create a pointer with the name my array, creates a pointer that points to an int with the name my array. Let me kind of do this. Alrighty. And then we also talked about pointer arithmetic. So we said if I print the pointer, I can say the value of the pointer my array is %sign p\n comma my array. It's really the same thing as saying the address of my array is %sign p\n comma my array. It's the same thing. Let me actually put this here and let me just comment it, but it's really the same thing. So if I hit play, you will see it's going to print a value in hexadecimal, and that's really the address. And we did say that we can do pointer arithmetic. So you can add integers to pointers, and this is a pointer. This is a pointer that points to an int because this is an array of type int. So I can say print if the value of the pointer +1 is %sign p\n my array +1. So let me ask you a question here. What do you think that's going to print? So we know that the value of my array, which is really the address of my array in this case, because my array is a pointer, is going to be that. And then the question is, if we add 1 to it, what do we end up with? I think someone did send something. Let me see. 20. No, it's not 20. So if you take this and add 1 to it, it will be the address +1. What's the address +1? I mean, this is a value in hexadecimal, right? This is a value in hexadecimal, and you should be able to add, 1 or 2 or 3 to it, or 4 or 5. It's not very difficult. What would happen if you take this, which is really the address of the array, which is really the value of the pointer, and add 1 to it? Katie is saying this one is going to become D. So we're going to add 1 to it. We're going to end up with D. Is that right? Do we agree with this? Let me tell you that this is not the correct answer. What is the correct answer? I think you forgot what we covered yesterday. So this is pointer arithmetic. This is not integer arithmetic. So what is so special about pointer arithmetic? So Grace is saying it should be the address of the second item. Okay, what is the address of the second item? Okay, so it will be the address plus 4. That is absolutely correct. So when you add 1 to a pointer, the value that we're going to be adding is going to be determined by the thing that this pointer is pointing at. So this is a pointer that points to an int, and the size of an int is 4 bytes. So when you add 1, you essentially add 4 bytes. That's how it works. This is pointer arithmetic. You don't want to forget that. So essentially, you're adding 4 to this. If you add 1 to this, you'll be D. If you add another one, E. And then you add another one, F. And then you add another one. What would happen? What's after the F in hexadecimal? Is there something after the F? Or is the F the highest single digit value? Okay, so it is the highest. Because of that, this E is going to increment and you're going to go to 0. Just like how we do it in decimal. Once we go to 9, we go to the next digit and we make the 9 0. So when you add 1 to 19, this one's going to become 0 and this one's going to become 2. So it's the same thing. When you add 1 to this one's going to become 0 and this one's going to become F. Because after the E, there's an F. We can try. If you don't believe me, we can hit play and we can see. Do you see the answer? So what would happen if you add 2? Well, if you add 2, it's going to kind of add 2 4 bytes. So each one that you add, you're adding 4 bytes. If you add 2, you're going to add 2 4 bytes. Essentially, you're going to be adding 8. So you're going to take this one and you're going to add 4 to it. And that would be, in this case, 4 here. So every one that you add, you're essentially adding 4. This is pointer arithmetic. Of course, if we had an array of characters, each one that you add is going to be 1 because the size of a character is 1 byte. If you have an array of shorts, each one that you add is going to be 2 because the size of a short is 2 bytes. If you had an array of double, each one that you add is going to be 8 because the size of a double is 8 bytes. So, excuse me. So I hope that kind of makes sense. And we did some examples yesterday. So, and this was a good review also. So if you feel that you need to review that stuff, maybe you need to watch the stuff that we covered yesterday. Do you have any questions before we move to a new topic? Okay. So let's talk about two simple things. One of them is another way of declaring arrays and giving them values. So you can do this. This is perfectly allowed, but typically people do not do that because this is kind of it's a long way of assigning values. So what people typically do is the following. They say int, let's say my second array, and they can do 3, and then they can use the square brackets, and they would do 100, 12, 20. So this is the same thing as doing this. And you're going to see that actually more often than this. Now, here's something interesting. Because you're giving the values at the same time of kind of declaring the array, you actually do not have to give it 3. So C, the language C, is going to know because it has, 1, 2, 3. It'll know that the size of this one's going to be 3 elements. So it'll just allocate 12 bytes. It's going to put 100 in the first 4 bytes, 12 in the second 4 bytes, and 20 in the third 4 bytes. And of course, you can print anything you want. The first value is %d\n, my second array 1, and let me hit return here, return 0. And of course, you can see it printed 12. Of course, you can use the dereferencing notation. So you can say, the first value is dereference my second array, and that's going to be the same thing. Let's do the second value, print if the second value is $d\n, comma, my second array. Oops, I should have done 0 here. Why did I do 1? So my second value here is going to be 1, and print if the second value is $d\n, and then dereferencing my second array plus 1. By the way, if you see that I have a mistake, even if it's minor, please let me know, because this might kind of make things confusing to you or to other students. And I think yesterday there was a minor silly mistake that I made that, let me actually find it. Let me open my Keynote. Yeah, so the mistake was here. It's a really minor mistake. I say here, this is the space for the first element, second element, third element, fourth element, and this is the fifth element. So I still have fourth, and this should be fifth. It's a minor mistake. I think this one's not gonna make anything confusing, but I do want you to kind of point out any mistakes that you see, even if they're minor. All right, let's move this away. All right, so let's hit play and see if everything will run as expected. You can see here, the first value is 100, it printed twice. And then the second value is 12. It also printed twice. All right. So now I want to talk about the size of arrays. So I'm going to ask you a question, and let me actually comment this one, comment this one, comment this one, comment this one. And let's say print if the size of my second array is %, unsigned long, \n, and I'm going to do the size of my second array. What do you think that's going to give me? I'm not going to hit play yet. I want you to kind of think about it for a few seconds. What do you think that's going to give me? Okay, 3. That's one answer. The other answer is the number of bytes. Or 12, kind of that's the number of bytes. Okay, that's good. All of those are good answers. There's another good answer that you are not thinking of, and that is, since my second array is a pointer, it might be the case that the size is 8, right? I mean, that's also another good answer. So the answers are, one answer was 3, and that is, of course, the number of elements. And I would say 8 is not a bad answer as well, because since my second array is a pointer, it might be, the size of a pointer. And the third answer would be 12, which is the number of bytes. All of those are actually, good answers. The correct answer is going to be this one, 12. So even though my second array is a pointer, because it's defined as an array, it actually would not be 8, which is the size of a pointer. It would be the number of bytes. So we can hit play and you can see it'll be 12. All right, so how can I get the number of elements? So let's say I'd like to get the number of elements. How can I do that? I mean, what do you think we can do? The length, I mean, the number of elements, that's what I mean. So I'd like to get 3. How can I get the number 3 from 12? What do I need to do? I need to divide it by 4. And why is it 4? Because the size of each integer is 4. So I need to essentially divide it. I need to take this and divide it by the size of each element. So I can actually do division the size of the first element. This is really a very good way of doing it. Let me pause here and make sure that you understand what I'm doing. So instead of hard coding 4, which I could, it would be more robust to get the size of the first element, which is 4 bytes. So that if I change that to short, it'll still be correct. So let me kind of demonstrate that. If I have 4 here, let's just do 4. Let's assume that I'm gonna just do 4 and I hit play. And you can see it's saying 3, obviously not bytes, 3. Let me actually do this, and let me keep this, and let me say the number of elements in my is %d in this case. Actually, it could be unsigned long, that's okay. And let me remove bytes. So I can do that. And you can see it says the size of the array is 12 bytes, the number of elements is 3. Now let's say I change that to short and I forget to change this 4. Then it's not going to give me the correct answer. You can see if I hit play, it'll say the size of my second array is 6 bytes. This is correct because we have 3 shorts. Each short is 2 bytes. But then it's saying the number of elements in my second array is 1. That's wrong. It should be 3. So what I was proposing, instead of hard coding 4, we can just say the size of the first element. And that, if you say short, the size of the first element will be 2. So it'll be the correct, division. If you use an int, the size of the element is going to be 4, and you're going to use the correct division. Does that make sense? Give me a thumbs up or thumbs down. Let me hit play here. Okay, so that kind of makes sense. Perfect. All right. I think what I'm going to do is I'm going to stop the recording here and I'm going to start a new recording and I'm going to talk about functions, just kind of basic functions. And then maybe I can stop the recording and create a third recording and we can talk about functions and arrays and pointers. So maybe that's what we should do. So we can do half an hour of each, more or less. Let me um, let me do that. Let me stop the recording